Have you ever really stopped to think about the invisible forces that are, well, running our entire world? I mean, from the light hitting your screen right now to the music playing in your car, it's all powered by this incredible hidden dance between two fundamental forces. Today, we're going to pull back that curtain. We're going to get into the story of electric fields and magnetic fields. Let's do this.
And just a quick heads up, this is part 10 of a pretty extensive 20-part series. It's all based on a detailed report on radio frequency propagation that was put together by the RFI detectives, who are part of Virtualization Options LLC. So, we talk about electricity and magnetism all the time, right? But what's the real story there? Are they just related? Like maybe distant cousins who see each other at holidays? Or is there a much deeper, much more secret connection? Well, that's the exact mystery we're going to solve today. All right, let's meet the first character in our story, the electric field, or as we call it, the E field. This is the force that comes from the very, very basic building blocks of matter itself, electric charges. The best way to think about it is like a force field. Yeah, really. Every single charged particle, whether it's a positive proton or a negative electron, generates one of these. It's this area of influence that basically tells other charges what to do. If you drop another charge into this field, the field lines literally show you which way it's going to get pushed or pulled. And E-fields, they follow some very specific rules. Think of it like this. Their field lines are born on positive charges and they die on negative charges. They always point from positive to negative, so they have a clear starting point and a clear ending point. And trust me, that little detail is going to be super important in a minute. And now let's bring in our second character, the magnetic field, or the M field. Now, if the E field is the force of a charge just being there, the M field is the force of a charge in motion. You're definitely familiar with this one from the magnets on your fridge, right? But the deeper truth is that magnetic fields are actually created by moving charges. That flow of electrons through a wire, what we call an electric current, that creates a magnetic field all around it. And this is where M fields get kind of weird and wonderful. They always come in pairs, a north and a south pole. If you take a bar magnet and you snap it in half, you don't get a separate north pole and south pole. Nope, you get two brand new, smaller magnets, each with its own north and south. This means their field lines have no beginning and no end. They are always continuous, closed loops. So let's do a quick recap. We've got E fields, which come from charges just sitting still, and their lines start and stop. Then we've got M fields, which come from moving charges, and their lines just loop around forever. They seem like two totally different things, don't they? Well, that's where the story gets interesting. So the story takes this huge turn back in the 19th century. Scientists started noticing that these two forces, which everyone thought were completely separate, weren't quite so separate after all. And the very first clue, as it so often happens in science, came completely by accident. I mean, you gotta love this story. So Professor Oyerstedt is in the middle of giving a lecture, and right there, in front of everybody, he sees a compass needle just start twitching the moment he turns on an electric current in a wire nearby. He had just stumbled upon the first solid proof. An electric current creates a magnetic field. Now, Oersted's discovery, it kicked off a scientific revolution. Brilliant minds like Faraday and Maxwell, they built on his work, and they soon realized this connection was a two-way street. Get this, a changing magnetic field can actually create an electric field, and a changing electric field creates a magnetic one. They literally create each other in this endless, self-perpetuating dance. So are they just connected, or is there something even deeper going on? Well, this leads us to the big reveal, and I'm not kidding, the true relationship between E and M fields is one of the most mind-bending and honestly beautiful ideas in all of physics. Just let that sink in for a second. This quote really gets to the absolute heart of it. Special relativity, that's Einstein's whole idea that things like space and time can look different depending on how fast you're moving. Well, it turns out the same thing is true for these forces. Magnetism isn't really a separate force. It's just what the electric force looks like when it's moving relative to you. So it all comes down to your perspective. Imagine a single electron, just sitting there. To you, standing still, it only has an electric field. Simple. But now imagine I fly past that exact same electron in a super fast spaceship. From my point of view, that electron is a moving charge. It's a tiny little electric current. And because it's moving relative to me, I will measure both an electric field and a magnetic field. It's the same particle, the same phenomenon. What we call it just depends on our own motion. And that right there is the big secret. There is no separate electric field and magnetic field. There is only one unified thing, the electromagnetic field. It's a single fundamental force of nature that just puts on different masks depending on how you're looking at it. Okay, I know that's a really cool piece of physics, but what's the payoff, right? Why does this unified field matter so much to us in our everyday lives? Well, the answer is pretty much everything.
Remember that endless dance we talked about? A changing E field makes a changing M field, which then makes a new E field, and on and on. This chain reaction just keeps itself going. It doesn't need any wires. It literally pushes itself forward through empty space. That's what we call a self-propagating wave.
And check this out. This is one of my favorite, truly mind-bending examples. Look at this simple circuit. We all learned that the energy travels inside the wires from the battery to the bulb, right? Wrong. The energy actually flows from the battery through the electromagnetic field in this space around the wires, and then it dives into the light bulb. The wires are just there to guide the field. How wild is that?
And here is the absolute kicker. When the genius James Clerk Maxwell put all the math together back in the 1860s, he calculated the speed of these self-propagating waves, and the number he got was this one: the speed of light. It was in that exact moment he realized that light itself is an electromagnetic wave.
So this unified field isn't just some abstract idea on a blackboard. It's the source of this entire spectrum. The radio waves that bring music to your car, the Wi-Fi in your house, the actual visible light from the sun, the X-rays at the doctor's office, they are all the exact same thing. They're all just that endless dance of E and M fields, just wiggling at different speeds. So we've seen how these two forces that seem so totally different, one with a start and end, one that loops forever, are actually just different points of view of the same single fundamental thing. The secret was hidden in plain sight the whole time. And that kind of leaves us with this final big thought. If a force as basic as magnetism is really just an illusion caused by our motion, what other deep connections might be hiding under the surface of the world we see every day, just waiting for us to change our perspective?